All right, so welcome to 7.6, plotting linear inequalities. So we're going to remember how to plot a linear function first. Well, y equals 4x minus 6 is in y equals mx plus b form, slope-intercept form. So we can realize that the y-intercept is 0, negative 6. And the slope is 4, and we have to remember the slope of 4 means over 1, run a 1, up 4. So over 1, up 4, over 1, up 4, and so on. And once we have enough points, we draw a line through them. And let me get that, and lines have arrows on the end. And along that line, right, 0, negative, oof, I missed badly. I want to do this again. So 0, negative 6, right? And then we have here. So that's why we have erasers. And so all the points that make this equation true fall along this line. Like 0, negative 6 make it true, or as in, let's just show you that, right? When x is 0, 4x minus 6 equals negative 6. 0, negative 6 is on this line. And when x is 1, 4 times 1 is 4, minus 6 is negative 2. And so 1, negative 2 is on this line. And I could put a half in there. And half, 4 times a half is 2 minus 6. All right, 2 minus 6 is negative 4. And so 1/2 negative 4, which is right there, is on that line. And there are an infinite amount of points along that line, and there are all 3 of the combinations of x and y on that line. That's a linear function. Now what we're going to do is linear inequalities. They look like this. All these points in the shaded area make this one true. This is a graph of y is greater than 4x minus 6. So we just graphed 4x minus 6. And so notice the line is dashed because now the numbers or the ordered pairs along the line do not make it true. It's like the open circle we just did. So we have a dashed line. But all these combinations of ordered pairs, like this ordered pair here at negative 5, positive 2, if you put that into that inequality, it will make it true. And all the ones over here, like 6, negative 7, will not make it true. And that is a linear inequality. All right, so we do it pretty much the same way. So we have y is greater than negative 3x plus 2, right? The y-intercept is 0, 2. The slope is negative 3, right? Negative 3 is down 3 over 1, down 3 over 1, like that. But it's going to be greater than. It doesn't equal that. So we're going to make a dashed line. Those of you doing this with pencil have an advantage over me with my computer here. But we're going to make a dashed line. And then what else makes it true? Well, all the numbers that are greater than negative 3x plus 2. So all the numbers up in this area. Now I'm stopping at the square, but it goes on forever. Now this is considered above the line. It looks sort of on the right, but it's what the number is when it's greater, it's above the line. Okay? And that's what you do. So let's try another one. Hold on. There we go. So plot y is less than 1/2 x minus 5. So the y-intercept is 0, negative 5. The slope is 1/2. 1/2 is over 2 and up 1. So over 2, up 1, over 2, up 1, over 2, up 1. And you can do some backwards. And once again, it's a dashed line because y does not equal 1/2 x minus 6. Y is less than that, right? So we're going to make a dashed line. We're still going to put arrows on the end. And we're going to shade, once again, right, underneath. You can use any color. I'm going to use red this time because I accidentally clicked on red. But that's how you graph y is less than the line 1/2 x minus 5. All right, all the points in the shaded area are solutions, right? So let's see. This is a graph of y is greater than x plus 7, right? It has a y-intercept of 0, 7, and a slope of 1. You can see that. So is negative 6, 4 a solution? Well, there's two ways to check. Negative 6, 4, is it in the shaded area? Yes, it is. So it's a solution. What does that mean? It means if I put these numbers in here, it should make the inequality true, right? Y is 4, x is negative 6. So is 4, negative 6 plus 7 is 1. Is 4 greater than 1? Yes. So you could check it without the graph, but if you have the graph, you just look in the shaded area. Negative 4, 2. Negative 4, 2, it's a little short, a little below the line, so it should not make it true, but let's check with the inequality. So we have y is 2, not 4. Y is 2. I'm going to put the negative 4. And negative 4 plus 7 is 3. Is 2 greater than 3? No, this is not greater than 3, and so it is not a solution. If it's on a dashed line, it is not a solution as well. Okay. Now we have or equal to, so the line now becomes solid. It's just like filling in the circle with other one variable inequalities. So let's plot this, right? The y-intercept is 0, negative 5. The slope is 1/4, which is over 4 up 1. Over 4 up 1, over 4 up 1. We can do some backwards here. But now we're going to draw a solid line because it's or equal to. So that noise you hear is me putting my ruler on the screen. We're still going to put arrows on the end, make it nice and long all the way through. And now, we need the y's that are less than or equal to 1/4 x minus 5. So all those down there make it true, plus the blue line makes it true. We've plotted the inequality. All right. Points, if on a solid line, are solutions. Points on dashed lines are not. So is the point a solution to the inequality y is less than or equal to 5x minus 2? Well, here's 2, 8. Looks like it's right on the line. Let's see what happens when we put it in here. And 5 times 2 is 10, minus 2 is 8. Yeah, 8 is less than or equal to 8. So yes, this is one of the many solutions to this inequality. All right, now standard form is a little trickier than slope-intercept. We're going to see that here. So we're going to plot this inequality. So how do we plot in standard form? Well, we could convert it to slope-intercept, right? We could subtract 3x from both sides and do that. But typically we find the intercept. So to find the y-intercept, you make x equal to 0. So let's do that. So 3 times 0 plus 4y equals 12 for that, just like always. And divide by 4. So y equals 3. So the y-intercept is 0, 3. The x-intercept is where y equals 0. So we divide both sides by 3, and x equals 4. So the x-intercept is 4, 0. Now, it's got an or equal to, so it's a solid line. So let's draw this, right? So if we were doing the linear function, 3x plus 4y equals 12, it would be the line we're about to graph. So let's do that. And there it is. Now, it's not, just because this is greater than, it does not mean that you shade above the line. Okay, and that's the tricky part. That only works when we're in slope-intercept or when you have y by itself. It doesn't work here. So what do? So what you do is you put 0, 0 into this inequality. Now you can put any point. You can put 10, 10 in there. If 10, 10 makes that work, that's in the shaded area. If it doesn't make it work, it means the other side's the shaded area. We tend to use 0, 0 just for the same reason we just use zeros for finding intercepts. It makes it go faster. So let's put zeros in here and see what happens. So you get 3 times 0 plus 4 times 0 is 0. Is 0 greater than or equal to 12? No. Right? So no. 0, 0 is not a solution. So that means the other side is the solution. So you would shade the other side because 0, 0 is not a solution. And you need to do that extra step for standard form of an inequality. Okay, and so the answer is no. So let's plot this inequality. Let's find the intercepts. So when x equals 0, negative 6y equals 12, divide both sides by negative 6, y equals negative 2. So 0, negative 2 is our y-intercept. For the x-intercept, we're going to make y equal to 0. And that crosses out, divide both sides by 3. X equals 4, so the x-intercept is 4, 0. Notice it's less than, so it's not or equal to, so it's a dashed line. So we're going to dash this line up here. Now we have to decide, is 0, 0 a solution? So we're going to put 3 times 0 minus 6 times 0 is less than negative 12. Is 0 less than negative 12? 0 less than negative 12? No, it is not. So once again, 0, 0 is not a solution. So we are going to shade the other side. So once again, it was a no. 0 is not less than negative 12. All right, so plot y is greater than negative 5. All right, so now we have y by itself. So this is sort of in y equals mx plus b form. M is 0. That's why there's no x. So what kind of line has a slope of 0? Horizontal, hopefully you just said. So this is the b part. So the 0, negative 5. Having a lot of negative y-intercepts in this lesson, and it's going to be a horizontal line, and it's going to be dashed because, right, there's no or equal to. And now this is in y equals mx plus b form, so we don't need to check 0, 0. We could, that would still work, but it's y is greater than negative 5, so we're shading above this line. Do whatever you want here. Try to be neater than me. Let's see, is 2, negative 10, I wish I was neater, is 2, negative 10 a solution? Well, let's see that. 2, negative 10 doesn't look like it's going to be a solution, so that would be no. But let's see. When we're going to put, it doesn't matter what x is, right? When y is negative 10. Is negative 10 greater than negative 5? No, it's not. It's less. So it's not a solution to the inequality. All right, so that's in standard form. So, well, it has a negative there, so not everyone thinks it's in standard form, but it's in ax plus by equals c form. And so y-intercept, so we're going to make x equal to 0. And we're going to use an equal sign here. So y equals 8, so 0, 8 is our y-intercept. There's a positive y-intercept finally. X-intercept, y equals 0. Divide by negative 4. X equals negative 2. Negative 2, 0 is it's greater than or equal to, so it's going to be a solid line. So there it is. Now, this is in standard form. We can't just look at it. So we're going to see if 0, 0 is a solution. Is 0 greater than or equal to 8? 0, 0 is not a solution once again. So then we're shading, and this looks like it's to the left of it, but it's not. It is above the line. And so we're going to shade above the line. And there we go. Good luck with the homework. Shade neatly.